Hi everyone, welcome back on Study Room. In this video, we will learn some concepts of geography and some important concepts of climate. We'll start with this brainstorming question. So, pull up the strings of your brain and let's start. Our first question is why are most of the world's deserts located in the western margins of continent in subtropics? Yes, that is true. If you observe the map, we will see, for example, in this map, we will see all the deserts in all the continents are almost located in the western margins. Okay, they are in the western. For example, in India, we have Western Ghats, and all the deserts are in Rajasthan, Gujarat. Okay, for example, Run of Kutch. So they're also located in western margins. Likewise, if you notice in Asia and Europe and even in North America, the deserts are located in western margin. What is the reason? What magic is happening here that all the deserts are located in the west side? This is because they are they are prevailing very western side. Now, what do I mean by that? I mean that the tropic winds are easterly winds. Okay, they travel through the east. So in the tropics and in subtropics, the in the direction in which the winds travel are mostly easterly travels. Okay, and when it moves to the eastern sides, which mean opposite to the west, when it moves to the eastern sides, so the wind which move towards the eastern sides are dry winds. Okay, usually they are dry winds prevailing very hot climate in the areas where they reach. Okay, so that is the reason why most of the deserts are in the west margin. Also, it leads to no rainfall. Okay, at that time there is no rainfall, of course, because the winds are dry. In the tropics, most of the winds which have moisture travel through the eastern side. Okay, so if the wind of the moisture move towards the eastern side, definitely in the west there will be dry, and that leads to no rainfall. Okay. Now we'll discuss few concepts of geography here and few important concepts to understand climate. One first is latitude. Latitude, I know we have discussed, but now this latitude is in the reference of India. Okay, so we'll study the climate of India through these factors. Now, one important point to understand here about India is that Tropic of Cancer passes through India. Okay, Tropic of Cancer, it passes through India, as you can see in the diagram, from Run of Kutch in west. Okay, it starts from Run of Kutch in the west, and in east it leads towards Mizoram. Okay, now, what does this mean? So, when Tropic of Cancer is passing in Run of Kutch and till Mizoram, this means that the southern part of India, which means below the line, okay, all the southern part of India have tropic region. Okay, they are tropic region. So this part is tropical region, we call it, or tropic region. Okay, above or in the north side of the Tropic of Cancer, it does not lie nearwards, so that's why it is subtropical region. So in India, we see several characteristics. So for example, the climate of Kashmir will not match to the climate of Kerala or Tamil Nadu, for example. Right? Why is that so? Because these two are different. These two are different because they are separated by a Tropic of Cancer, which leads to southern continents or southern state having tropical climate and northern state having subtropical climate. So we have characteristics of both. Very important to understand. We have subtropic plus tropic, so we have characteristics of both. Okay, and these characteristics leads to our lifestyle, obviously, because however the environment we live in, our lifestyle depends upon that. Our food, our clothing, our way of behavior, and even our schedule depends upon that. All right, so majorly this is about the latitude. Next, we will study about altitude. Okay, so for latitude, we understand the Tropic of Cancer passing through it and giving different characteristics in terms of climate in our country. Now we'll discuss about the altitude. Do you think altitude, which in literal, in easy language, means height? Okay. Do you think height make a very important factor in understanding climate? Well, it does. It does make a very important factor. We'll understand how. So, firstly, in Indian context, our Indian subcontinent, which means the northern part experience very mild climate. Now you all must be wondering, ma'am, the climate is not very mild in northern part, it's very cold. Yes, indeed, it is very cold in Himalayan region or the northern subcontinent. But the fact here to understand is that the colder winds that is coming from Central Asia in our country are being holded by Himalayan mountains. So all the Himalayan mountains that are present here play the role of like a barrier and play a role like a big protective door which help us to prevent the colder winds that are coming towards us. So if we compare it to rest of the Central Asia, in India it is comparatively milder. Now, with the help of the map, we can understand about the elevation zone, okay, in meters. So, firstly, the average height of mountains in the north side mountains have average height of 6,000 meters. I'm sorry, it is 6,000 meters, means the height of mountains is approximately 6,000 meters. If we compare it with the elevation of south, elevation of coastal areas, in coastal areas it is only 30 meters. Okay, so here are the elevated areas. So where there is light yellow part, it is greater than the mountain altitude is greater than 3,500 meters, and where there is blue, which is like less than 100-meter elevation. So definitely in the areas where it's more than 3,000 meters of altitude, they experience little extra winter there. Due to altitude, the climate is also very cold and very low. So that is why it's colder in these part, and the blue part where the elevation is less, the climate is comparatively high. Okay, so these are the reason for altitude. Next, we'll understand another very important concepts: pressure and wind. Now we'll understand this through a diagram. So India has unique pressure and wind system. In Himalayan region, in northern Himalayan region, when there is winter. Okay, first we're talking about winter. When there is winter in Himalayan northern Himalayan region, it as we all know, in the areas where there is height and altitude, it generates cold wind, right? So these cold winds are high pressure, have high pressure, and they move towards the downwards. Okay, and move towards the downward, I mean from north to south. Okay, so for example, they move towards the south. And when they move towards the south, so basically they move towards the low pressure areas. Okay, so these are basically into low pressure. Now, due to the equator and due to the reversal of winds, in summers we have a very different situation. It is not directly reversed to high pressure to low pressure and low pressure to high pressure. We will understand how. Now let's understand the reverse method, the reverse changes which happen. Okay, so earlier we have understood what happened in winters, but now we will understand what is there in summers, what happened in summers. Okay, so in summer the reverse pattern which follow is that winds which are coming from the northern region, northern Himalayan region, are low pressure winds. Okay, so these low pressure winds cannot move downwards because low pressure winds are very they are light, so they obviously will move upwards, not downwards. Okay, so now it comes to high pressure which is built in coastal areas. Okay, so due to winters, now the high pressure is built in the coastal areas. So these high pressure build will further go down to the sea. Okay, so if we understand the map, for example, this cross is India. Okay, and these lines are basically symbols of ocean. Okay, so here we have Arabian Sea and here we have Bay of Bengal. Now, from these coastal areas, the winds are moving downwards towards the ocean. Okay, and what is below Tropic of Cancer? It's equator. Okay, so when these rivers reaches to equator, as you can see here, it moves towards the right. Okay, move towards the right, which leads to a type of wind which we call southwest monsoon winds. Okay, and due to this hot and cold mixture, this particular thing leads to large moisture in the winds. Okay, it's mainly due to the winds traveling down towards the sea and the equator. All right, so these are majorly this is how the pressure and the surface winds work. Now we will understand about upper air and circulation. Okay, now our second point here is upper air circulation. Upper air circulation is very easy to understand. So now continuing to this diagram only, we know that high pressure winds move towards the equator. Okay, now these low pressure winds move upwards. Okay, so when they go upwards to the latitude, I cannot draw above it. So if it goes upwards around 27 degree to 30 degree north. So what is there in these areas? So you have to remember that around 27 to 30 degree north, it's a pressure belt is. Now the kind of the wind these jet stream release are called subtropical westerly jet streams. Okay, and this is basically upper circulation. In upper circulation means that these winds moving towards upwards towards 27 to 30 degree north, and the wind that they release are are called subtropical westerly jet streams. Okay. Now we'll understand western cyclonic disturbances and tropical cyclones. Now in the western cyclonic disturbance means it's a wind which are coming towards the Mediterranean Sea. Okay, because Mediterranean Sea is in west. Okay, so these are winds coming towards the Mediterranean Sea. And where do they affect in India? They come to this region, the northern Himalayan region. Okay, and this leads to affecting and or influencing the weather and climate. Okay, next about tropical cyclones. Tropical cyclones are again very simple. These are the winds which flow towards easterly. So tropical cyclone leads to having heavy rainfall in the time of October and November in northern region. Okay, so it definitely affects the our climate due to the cyclones. Okay, so these are tropical cyclones and cyclonic disturbance. Now we'll understand about this term called Coriolis force. Okay, what is Coriolis force? Okay, Coriolis force. Now you must be getting confused. Where is are the wind coming? Where are the wind going? Well, it's completely unsettled because the earth is constantly moving. So the pressure belts are constantly rotating. So cannot be a single place where there can be high pressure all the time. Okay, that's why we have further divided into 4 seasons, and that's why we have these latitude and belts. Okay, but what is the reason behind this? For example, if I ask you to stand on the North Pole and I give you a ball and I want you to throw this ball, okay, throw this ball directly towards a point A. Do you think this ball will go towards point A? No, it will move certainly towards right, okay, right to the person, and it will fall somewhere here. Okay, it will move towards this direction, move towards right. Okay, and similarly, if I ask you to stand in southern pole, south pole, and if I give you a ball and ask you to directly point it out in in A, do you think that will happen? No, that will not happen because the ball will somewhere reaches to the left side. Okay, which means the direction will be somewhere here. Okay, somewhere like this. and in this case the direction will be somewhere like this. So if you see the faces of both the things, both the lines are very different. Okay, so basically this is Coriolis force. Now let's make it more clear to you apart from example. It is simply northeasterly surface winds originate from tropical region. So whatever the winds we see in tropical region or in the northern sides, what are their origin? They originates from subtropical. It means if the child is not, so its mother will be subtropical. Okay, and in the and it blows towards south. Okay, so south is getting affected. Okay, affected and deflected due to Coriolis force, means that the wind of moving towards this direction, and in south it moving towards this direction. It should be like this. Okay, but it moved towards this direction is due to the Coriolis force, due to the movement of the earth surface. Okay, so they differs from their actual path and the path they intended. Okay, they move slightly opposite. Okay, if they intended is here, their actual path will be here. Okay, which means opposite. So this is basically Coriolis force, and we have studied this in concept of northern easterly winds. Okay, simply let me revise it for you if you're getting confused. Wait. Yes, simply the northern easterly surface winds. Northern easterly surface winds means the winds are of northern sides or northeastern sides. Okay, so winds are of this side, originates from subtropical. So north is the daughter and mother is subtropical. Okay, now now the mother is subtropical, and they blow towards south. When they blow towards south, their direction actually should be like this. Okay, they should move like this, but their actual path changes. This is they get deflected. Okay, so if it has to go like this, it will move somewhere like this. Okay, if it has to go, the ball should go like this, it will not go like this, it will go like this. Similarly, if in this case the ball should go like this, but it will not go like this, it will move towards little here due to the movement of the earth and movement of all the tectonic plates as well. Okay, so this is Coriolis force. All right. Now, first we will understand what is southwest monsoon. I've already studied southwest monsoon. Let me revise it for you. So, southwest monsoon are basically, for example, now they are heavy winds, they are cold and dry winds of high pressure during high pressure. This is P. I'm sorry. This is high pressure during winters, and these high pressure winds move downwards to the coastal areas. Okay, and which has low pressure. Okay, which has low pressure. Now this happens in winter, but in summers the situation are little different. What happens in summers? So in summers there is low pressure in this area, and this area has high pressure. Okay, coastal areas has they release high pressure. Now when they release high pressure, the wind moves towards the equator. So this is the equator. So this is the equator, and shape of India is somewhat like this. Okay, which means the water is here, the water is here. Now if the wind moves towards the coastal areas, means towards the sea and goes down to the equator. Okay, when it goes down to the equator, it takes the right turn, which releases a kind of wind with lot of moisture and wet wind, which leads to heavy rainfall in the coastal areas, and this wind particularly is known as southwest monsoon. Okay, simple, understood. Now what are the reversal factors of it? Reversal factor means that the wind which are coming towards equator were usually dry. Now it completely reverse. Okay, completely reverse means that the wind is now with lot of moisture and very wet. Okay, so it leads to heavy rainfall. It take the turns and somewhere take the rounds and come towards the coastal areas as very heavy winds, heavy in terms of monsoon. Okay, so this is pressure and wind condition, which is almost similar. Now we'll understand about this term which we have discussed in previous slides, jet stream. Let's put more focus on it. What are jet streams? Now, jet streams are basically a kind of pressure that winds create. Okay, so it's winds that are coming from subtropical region, easterly or westerly. So they come at a speed of 110 kilometer per hour, and in summers the wind are different. It's 184 kilometer per hour. So these winds come to a layer which outside the Earth's surface, which is stratosphere, and it does not pass through stratosphere. The air does not go above the space, right? It takes a turn back. So where it takes a turn back is what we call stratosphere. So it takes a turn back, okay, and the winds which are originating from subtropical eastern, they blows towards the peninsular India, okay, and west winds that are coming for west, okay, if they are coming towards west, they blows in to the south of Himalayas, okay. So if it's western jet stream, it will reach to Himalayas. If it's eastern jet stream, it will reach to peninsular India, okay. So these are the major concepts that you have to understand about jet streams. Now we'll in detail talk about India and the Indian monsoon. Very important. So India is a tropical and subtropical region both. What affects monsoon in India and what is the mechanism of the Indian monsoon? Let's understand. First is the differential heating and cooling of land and water. Yes, we have discussed this as well. So for example, if there is water in this area and there is land in this area, so land comparatively cools down or heats up faster as compared to sea. Sea takes time to cool down, sea takes time to heat up, okay. So in this area, definitely in the daylight, when there is day, when there is sun, in this area there will be definitely a low pressure, okay. So there will be a low pressure in this area, right, because it's dry and the particles are separated from each other. That's why they move upwards, okay. And in this area where in the daylight it is comparatively, this area will have high pressure, okay, and high pressure, it means that this will move upwards, okay. Now the merging of these things, now what will happen in the night? Let's understand the concept of night. Now, what happens in night is that, okay, this is the moon that I've drawn. So in night, what happens is, so this area has high pressure, okay, because this winds in the daylight have moved towards this side, and this area will have low pressure, okay. So so the high pressure winds that in the oceanic area, in the daylight it was high pressure, now they have moved towards the land sides, okay. So when it will go towards the landslide, it will definitely, the winds of high low pressure will go upwards, and this will lead to concentration in clouds, and this will lead to rainfall. This is a very simple thing. For example, it will be a emergence of both high pressure winds and low pressure winds, which has condensed and lead to precipitation. This is a very simple mechanism of monsoon, first place. Second, we understand about ITCZ. Now, let me draw a diagram to make you understand this. Now, we understand the concept of jet stream. Okay, what is the concept of jet stream? That wind is coming to the tropical zone at a very high speed and diverge, okay, and diverge and make a pressure of winds and create winds and go back, okay. So which are coming from eastern side move towards the peninsular, and which are coming from western side move towards the Himalayan region of our country. Now we will more detailedly understand about ITCZ. ITCZ, the name is quite big, but it's quite easy to understand. ITCZ, Intertropical Conversion Zone. So now this is the Earth that I have drawn. So we have several belts, right? So this is the equator, and we have several belts. I have very poorly drawn few belts here. Now you just don't have to understand the concept of belts that we have already discussed. So this belt has high pressure, low pressure, high pressure and low pressure. Now of course it keeps on changing. So for example, when there is for example, this area has high pressure and this area also has high pressure. So the area of high pressure releases the wind. Okay, they're moving, leaving the wind towards upward side. Similarly, this is moving towards upward side according to north, and this is moving towards upward side according to south. Okay. Now, what happens? So these wind come to a equator, and what do you think? They converge. They converge and make the jet stream. No, that's not how jet stream are made. So what do you think? The winds are coming from all the high pressure and meet toward in the equator and go like this. No, so that is not the case. Meet at a 0 degree. It's not possible that winds meet at a 0 degree and do this act. So how it happens is that there are extra layers which are added, or of 5 degrees Celsius. Okay, so there's an extension of 5 degree from each side that has been made. Okay, so wind come from here, not like a straight line, but they converge a little. Let me draw it more neatly for you all. So okay, so winds are now coming, not like a straight line. They're coming more like a converging part, and at 5 degree they started to escalate towards the jet stream. Okay, so here it's our jet stream. Now in this case only winds are coming not directly like a line, but little convergence and moving. So basically where this convergence is happening, for example, this is a straight line, right? Wind will not come like straight line and go. No, that will not happen. It's a very not logical thing to happen. So they started moving to 5 degrees Celsius. They started moving towards 5 degrees Celsius and go like this parallel at a point and then meet somewhere in the jet stream. This point is basically known as where this 5 degree thing is happening for the conversions. It's called ITCZ. Simple, intertropical conversion zone. Okay, got it. Next reason is presence of high pressure area and eastern Madagascar. So again, a high pressure area, the pressure is high. Obviously, where the pressure is high, the volume of moisture in the water will be obviously high. So it's obvious chances of rainfall. Next, take heating of Tibetan Plateau during summers. So it's majorly dry, but when there is like in the plateau. Now we'll understand about southern oscillation and how this works. So southern oscillation is very simple. It's just the reversal theory which works. So southern oscillation. So we'll understand this with the two concepts. Okay, first it's southern Pacific and second is Pacific Ocean. Southern Pacific and Indian Ocean. I'm sorry, Southern Pacific Ocean and Indian Ocean, not just Pacific Ocean. Yes, Indian Ocean and Southern Pacific and Indian Ocean are very directly connected with each other. Okay, because of the pressure belts which are almost same. Okay, so in whenever there is a high pressure in Southern Pacific, there will be a high pressure. There will be a low pressure. There will be a low pressure in Indian Ocean, which means that always it will be reversal in the pressure. There will be reversal. There will be reversal in the pressure between Southern Pacific and Indian Ocean. If in Indian Ocean it's it's high pressure, so in Southern Pacific it will be low pressure. It will be always opposite. If one is high, other one will be always low. So that is southern oscillation. Okay, simply. Now next we'll understand about onset of monsoons. So It is about the onset of monsoon, means what in what condition the monsoon occurs. So first important thing is that monsoon lasts 100 to 120 days, starting from early June. It starts from June and to mid September. Why it starts from June? It almost starts from 14th June, because in Arabian Sea, the Arabian Sea reaches to Mumbai 10 days later. Yes, due to all the other activities, the Arabian Sea, the waves reaches 10 days later in to Mumbai. Okay, so which leads to starting in mid of June to mid of September. Okay, now this in June to till September, where is a time where there is burst of monsoon. Like in the recent times, we have heard about different kind of monsoon season that is happening. We call it Musladhar Barish, Musladhar rains. Okay, and other names which we have given to rains, which are very, very on very, very high level. Okay, the centimeters are very, very high. Okay, so that is why. So the 100 and 120 days are basically the monsoon days between these two months, and it proceed into Indian Arabian Sea branches and the Bay of Bengal branch. Okay, so means that Bay of Bengal branch is moving is the winds of Bay of Bengal are moving in the direction they are moving in the direction and leads sorry the branches of Bay of Bengal are moving towards the northern side, taking the eastern way, and Arabian Sea taking the western way, moving towards the northwestern sides. Okay, so these are how monsoon system basically work. Now we'll discuss about withdrawal of the monsoon. Sometimes that monsoon begin in northwest and with states by September. Okay, it starts up in September and by early December monsoon withdraws. Means it's just monsoon by September. It just ends for rest of the country. Okay, so this is also because of the branches that travel. Okay, as long as they travel and take their circulation path, the rain will occur. We call it, sometimes we said, oh, it's raining in Himachal Pradesh, it might rain here soon. Why is that so? Because from Himachal Pradesh the clouds are being started forming and precipitating. Now due to wind course and everything, they will move downwards, and in the all, for example, very visible on the screen, as you can see, they are all moving towards the down, right? Because they are high pressure. Okay, so they move towards down. Now this map will help you understand the precipitation of Indian states. Okay, so this very, very lighter pink is where there is 0 to 60 mm, and the blue ones have 600 till 600 mm, means the very heavy rainfall is experienced here. Okay, so this is the reason for withdrawal of the monsoon.